Hello friends, in this video let us discuss about the functional circuit diagram of a MPPT charge controller. I have already explained the functional block diagram and the flow chart of the same in our previous video. If you have not gone through, please go through it so that you can able to understand the functional circuit diagram in a better way. So let us start now. So this is the functional circuit diagram where you have the input terminals from the solar panel is connected here. From here, it is going to be connected to the charge controller, buck converter, and then so on. So whether the panel should be connected to the buck converter or not will be decided by this switch, the MOSFET switch here. And this switch is controlled by this gate driver, and the gate driver is getting signal from the microcontroller. So the microcontroller will decide whether this switch is to be on and off based on two conditions. One is the panel voltage should be lesser than the panel maximum voltage. And the second one, the battery should not be overcharged. Okay, so the battery voltage, if it is already fully charged, no need of charging the battery again. So with these two conditions, this switch will be in on or off condition. So the signal coming from the microcontroller will enable this gate driver to keep the switch on or off condition. If the switch is on, so that means the current start flowing through this. So that means this current amplifier or the current sensor will sense the current and it will give the input to the microcontroller. Right. So this current which is coming from here is given to the microcontroller, and here we have gate drivers for controlling 4 different switches here. So this is a multi-phase buck converter. We are having a 2 phases. So here this is one phase and then another one is like this. Okay, so how it functions, let us see here. Now, say for example, you have a positive gate here. So when you give the positive pulse here, so what happens, the current flow takes place in this path like this. And in the negative or a negative pulse, when the negative pulse is given to this MOSFET, what happens? Then the current flow would go through this path. So if you have a pulse coming from the gate driver like this, so during the on time, the blue color path, this path will be considered, and during the negative point or negative point of the cycle, so what happens during the off time, the current flow will be in this path. So the on and off time will be controlled. So on and off time will be controlled. So during on time, it is charging the battery. During off time, it is not going to charge the battery. So if the on time is more, that means the battery is going to charge more. So that means the current which is flowing to the battery will be more if the on time is more. If the off time is more, that means the current which is going to the battery will be less. This is for one phase. In the other phase, what is going to happen? In the same way, it is going to function. See here, what happens here during the positive pulse or a positive this one. Here the current flow will go through this path, and during the negative pulse or a negative side, then the current flow will be in this path. Okay, so for both phase, this actually it is happening at the same time. Okay, so it is we need to give the pulses at for the two phases at the same time, so that the current which is coming here will be getting added up. So say if this side, if you are giving positive, then the current will be coming here, and the current also coming from this red path. So these two current will be getting added up. And if it is both are negative, so that means the current flow will be going to the ground like this. Or if you have one positive, one negative, so based on that, only one current will be available, the other one will be going to the ground. So based upon the amount of current requirement, you can have a flexible variations, so that the charging current can be varied. So this current which is going to the battery is monitored using this current sensing amplifier. So the battery charging rate is also monitored here using this one. And once it is going to here, and we have a voltage surge arrestor here. So this voltage surge arrestor will arrest the surges in case of any voltage surges. And after that, it is the load is connected to the battery. So either it may be inverter or direct this one. So the load current. So how much the load we are connecting, based on that, the inverter is going to take the current from the battery. So this also again is monitored using this current the sensor. The load current will be monitored by this current sensor. So these inputs also will be given to the microcontroller. So if the current taken to the load is very high, so in that case we need to disconnect disconnect the load from the battery. So the microcontroller will take the decision based on the load current. If the load current exceeds a particular limit, then what happens to the microcontroller will give the signal to this gate driver, and the gate driver will open this MOSFET so that the load will be disconnected from the supply or the battery. In case if the battery is drained, say for example, there is a lower cutoff value for the battery. In case if the battery is drained, that time also it will disconnect. Or if the battery is over discharging, like the load is taking too much amount of current, that time also it will open the switch so that the load will be isolated, or the load will be disconnected from the battery. So this is the important function of circuit diagram. So actually the signals from the current sensors, three current sensors as acting as an input, and we have a temperature sensor and a optical sensor. So these are the inputs, and moreover we have also the voltage sensor, and this voltage sensor, current sensor, and we have a light sensor, and we have also the temperature sensor. So these are the inputs, and we have explained the conditions. In what condition the panel should be disconnected and panel should be connected, and what condition the battery should be connected and battery should be disconnected, and in what condition the load should be connected and disconnected is already explained in our previous video. So based on these conditions, it is going to open or close the switches, and the charging current will be determined by this pulse width modulated signals which is coming from the microcontroller. So this is the microcontroller block, and this microcontroller, as I told you, it takes the input from all the sensors like voltage sensor, current sensor, and temperature sensor and light sensor, all these sensors. And according to the code, or according to the requirement, it gives the output signals to turn on and turn off the MOSFET or switches. So these are the sensors, current sensors. These three are the current sensor modules, and we have the temperature sensor here, and this is our optical sensor, and we have the voltage regulator here. So this is the voltage regulator, where this one is for 9 volt and this one is for 3 volt voltage regulator. And then also we have the voltage sensor here. So this is the voltage sensor unit. So these are the inputs, the voltage sensor, temperature sensors, and all these are going to be the inputs for the microcontroller. So based on the conditions, it is going to give a signal for the switches to on and off, so that connection and disconnection of a battery and panel is controlled. Also, the charging rate also will be controlled. So by controlling the charging rate, so we can able to obtain the maximum power point for the given ambient condition and load condition. Hope it is clear. I have not gone into very specific details of each and every component. I have just generally told what it is happening inside this circuit, because if you go to each and every component, it may take a lot of time to explain. So I have just given a in general idea. If you have any doubts, please let me know. So whatever the possible way I can explain, and I will explain to you. Thank you. Thank you so much.